Hello and welcome to this video. So in this video we will solve problem number 391 to 400 of polynomials and theory of equations. So you can download this PDF from my website. The link I will give in description. However, you should note that the link does not contain the date in the link, so it will always download the latest PDF. But if you want to know if the date has changed or not before downloading, then you can go to my website www.ashtavakar.org. Look at the second link. This specifies the date 2026 March 27th. So I updated it yesterday, and usually after every video I find some typing mistakes and then update the PDF. Sometimes update it daily, sometimes within 2 days. So make sure you observe the date before you download. Most of the time it will be newer. However, the name of the link does not change. The actual link does not contain the date. So if you download through description, you will always get the latest link. But it may be a duplicate to what you already have if the file has not changed. The other reason for giving this website is that the trigonometry book is also ready. It was completed on 24th January, and you can download the trigonometry book and study for yourself. Right now I'm writing the book on coordinate geometry. I'm in straight lines chapter, so once the chapter on circles is complete, I will upload it and you can download that as well. So with that out of the way, let's look at the problems of this set. So as always, I will say this, that when I am stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem, only then you should look at the solution. So without further ado, let's get started. Question 391 says that if m into x square plus 2bx plus c plus px square plus 2qx plus r can, you see the typo here, it's can be expressed in the form n into x plus k whole square, then show that ak minus b into qk minus r is equal to pk minus q into bk minus c. So now we look at the solution. So what we do is we let the given expression which we had to be equal. Okay. Now we compare the coefficients. Here we multiply m into x square and add with px square, we get ma plus p, which will be equal to n. Now coefficient of x would be 2bm plus 2q, which will be equal to 2nkx. We cancel out 2, we get mb plus q is equal to nk. And the constant term would be cm into r, which is cm plus r, that is mc plus r, which will be equal to nk square. Now, from all these conditions, we see that m into ak minus b plus pk minus q is equal to 0. Okay, so how did we arrive at this? So it should be m into ak minus b is what is given. So this is nk, so we multiply this with k, we get mbk plus qk. Or what we can do is we can multiply this with k, so we get mak plus pk is equal to nk, we subtract first two. So we get m into ak minus b plus pk minus q is equal to 0. So from this we get m is equal to minus pk minus q divided by ak minus b. And from the other two identities we have got m into bk minus c plus qk minus r is equal to 0, that is m is equal to minus qk minus r by bk minus c. So we equate the values of m and we arrive at the desired result, that is ak minus b into qk minus r is equal to pk minus q into bk minus c. Now we move on to question 392. It says that the real numbers, this should be x1, x2, x3 satisfy the equation x cube minus x square plus beta x plus gamma is equal to 0 are in AP. Find the intervals in which beta and gamma must lie. So we let the roots to be a minus d, a and a plus d, because it is given that the roots are in AP. So we sum the roots, and from Vieta's relationship, we get sum of the roots as 1, that is a is equal to 1 by 3. Now product of 2 taken at a time is equal to beta. So we get 3a square minus d square is equal to beta. Now we substitute a is equal to 1 by 3. We get 1 minus 3 beta is equal to 3d square. And product of roots is gamma. That is a into a square minus d square is equal to gamma, which is equal to 1 plus 27 gamma is equal to 9d square. Once we have all this, it is known that d is real, so 1 minus 3 beta will be greater than 0. So beta is less than equal to 1 by 3, and 1 plus 27 gamma will be greater than equal to 0. So gamma is greater than minus 1 by 27. Now we solve question number 393. It says that if equations x cube plus 3px square plus 3qx plus r is equal to 0 and x square plus 2px plus q is equal to 0 have a common root, show that 4 into p square minus q into q square minus pr is equal to pq minus r whole square. So what we do is we let alpha to be a common root. So we substitute it in the given equations. We get alpha cube plus 3p alpha square plus 3q alpha plus r is equal to 0. And alpha square plus 2p alpha plus q is equal to 0. We multiply the second equation by alpha and subtract. We get p alpha square plus 2q alpha plus r is equal to 0. Now from the second and third equation, we cross multiply. We get alpha square by 2 into pr minus q square is equal to alpha by pq minus r is equal to 1 by 2q minus p square. So from first two, we get one value for alpha. From the these two, alpha and 1, we get another value of alpha, and we equate them, we get the desired value. Now question 394 says that if c is not equal to 0 and the equations x cube plus 2ax square plus 3bx plus c is equal to 0 and x cube plus x square plus 2bx is equal to 0 have a common root, show that c minus 2ab whole square is equal to 2b square minus ac into a square minus b. So we let alpha to be a common root and we substitute in the given equations. We get alpha cube plus 2a alpha square plus 3b alpha plus c is equal to 0 and alpha cube plus a alpha square plus 2b alpha is equal to 0. Now since c is not equal to 0, therefore alpha cannot be a common root. Okay, because this c is not 0, we can't take out alpha, but here we can take out alpha. Therefore from 2, what we get is we take out alpha of common, and then what remains is alpha square minus a alpha plus 2b is equal to 0. That is our third equation. Now what we do is we take 1 minus alpha into 3. This should be 3. So we get a alpha square plus b alpha plus c is equal to 0. And from 3 and 4, we do cross multiplication, and that will give us our desired result. So there's quite a few typing mistakes here. There shouldn't be x. Now we move on to question 395. If equation x cube plus ax plus b is equal to 0 have only real roots, then prove that 4a cube plus 27b square is less than equal to 0. Now we let the roots to be alpha, beta, gamma. Then we have alpha plus beta plus gamma is equal to 0. Alpha beta plus beta gamma plus alpha gamma is equal to a, and alpha beta gamma is equal to minus b. Now we let y is equal to alpha minus beta whole square. So y is equal to alpha plus beta whole square minus 4 alpha beta. So we substitute the value of alpha plus beta here, which is equal to minus gamma. So this will become minus b, or it will simply become gamma square, and alpha beta will be minus b by gamma. So y is equal to gamma square plus 4b by gamma. That is, our equation becomes y gamma cube minus y gamma plus 4b is equal to 0. Also, gamma is the root of the original equation. So gamma cube plus a gamma plus b is equal to 0. Now from this equation and this equation, we subtract. So after subtraction, what we get is a plus y gamma minus 3b is equal to 0. So gamma is equal to 3b by a plus gamma. Then we substitute this in the given equation. We get 27b cubed by a plus y whole cube plus a into 3b by a plus y plus b is equal to 0. So we take the LCM, we get y cube plus 6ay square plus 9a square y plus 4a cube plus 27b square is equal to 0. Now we would get the same equation if we would have chosen y is equal to beta minus alpha whole square or gamma minus alpha whole square. Hence, the product of the roots, this equation is true for gamma, right? So, rather y, this is true for y. So similarly, y could be beta minus gamma over here and gamma minus alpha, it does not matter. Now, if you take the product of the roots, so what are the roots here? So the roots are alpha minus beta, beta minus gamma, and gamma minus alpha, all squared. So for the product of roots of this equation is minus 4a cube plus 27b square is equal to alpha minus beta whole square into beta minus alpha whole square into gamma minus alpha whole square. Now this is product of squares of quantities. So must be greater than or equal to 0. So 4a cube minus plus 27b square less than or equal to 0. Now we solve question number 396. Let alpha be a root of x square plus bx plus c is equal to 0 and beta be a root of minus x square plus bx plus c is equal to 0. Show that there exists a root of the equation a by 2 x square plus bx plus c is equal to 0 that lie between alpha and beta or beta minus alpha as the case may be, given that alpha and beta are not equal to 0. So it is given that alpha is the root of equation x square plus bx plus c, so we can write a alpha square plus b alpha plus c is equal to 0. And similarly, in the second equation, that is minus x square plus bx plus c, we substitute beta, we get minus a beta square plus b beta plus c is equal to 0. Now we let f of x is equal to a by 2 x square plus bx plus c is equal to 0. Now f of alpha will be minus a by 2 alpha square and f of beta would be 3 by, this should be 3 by 2 beta square. Now how do we arrive at this, or how do we arrive at this? There is some typing mistake here, seems like. Give me a moment. So alpha is the root, there exists a root of the equation a by 2 x square plus bx plus c. Okay. So how we have arrived at this is, you get f of alpha is equal to a by 2 alpha square plus b alpha plus c. But b alpha plus c will be minus a alpha square. So we substitute a alpha minus a alpha square. So we get minus a by 2 alpha square. And similarly, f of beta will be a by 2 beta square plus b beta plus c is equal to 0. But we have minus a beta square plus b beta plus c is equal to 0. So b beta plus c is a beta square. So we put in here, we get 3 by 2 beta square. Now we multiply f of alpha and f of beta, we get f of alpha into f of beta is equal to minus 3 by 4 a square alpha square beta square less than 0. Now given that alpha beta is not equal to 0, it is given that since the root will lie between alpha beta and beta alpha, so it will be less than 0. So f alpha, f beta have opposite signs, therefore f of x will have exactly one root between alpha and beta. Question 397 says that if a, b, c belong to the set of real numbers and a is not equal to 0 and the quadratic equation x square plus bx is equal to 0 has no real root, then show that a plus b plus c into c greater than 0. So the equation is given as 0. So f of x is equal to 0 has no real roots. Therefore, f of x will have same sign for real values of x. Now, f of 1 and f of 0 are greater than 0. F of 1 is a plus b plus c and f of 0 is c. So since f of x has same sign, if you multiply these two, which will be greater than 0 because both can be negative, both can be positive, but the product will be always positive. And we substitute the value of f of 1 and f of 0, we get a plus b plus c into c greater than 0. Question 398 says that if A less than B less than C less than D, then show that the quadratic equation x minus A into x minus C plus lambda x minus B into x minus D is equal to 0 has real roots for all real values of lambda. So we are given this equation and it is given that A greater than B greater than C greater than D. It is reverse. So it doesn't matter if, but let's assume that it is less than for now. Suppose that it's a typing mistake. Now f of B would be B minus A into B minus C less than 0. So B minus A and B minus C will have opposite signs. Whether you take greater than or less than, it will be of opposite signs. It will be less than 0. And similarly, f of D would be greater than 0. Okay, both can be positive or both can be negative depending on this sign being greater than or equal to. So f of B and f of D have opposite signs. Therefore, equation f of x will have one real root between B and D. Since one root is real and a, b, c, d, lambda are all real, the other root will also be real. Because non-real roots, that is complex and imaginary roots, always occur in conjugate pairs. So if one root is real, the other will also be real. Question 399 says that if ax plus 3b plus 6c is equal to 0, a, b, c in R, then show that the equation x square plus bx plus c is equal to 0 has at least one root between 0 and 2. So there seems to be some typing mistakes in this. I'm not sure about this. In any case, let's assume that there is no typing mistake. So we differentiate this equation x square plus bx plus c is equal to 0. So we let f dash x is equal, or there is some mistake here. There is some serious mistake. Assume that is f of x is equal to x square plus bx plus c. No, that won't work. It is f dash x, okay? X square plus bx plus c. So we integrate with respect to x. We get ax cubed by 3 plus bx squared by 2 plus cx plus k. We take LCM, we get 2x cubed, 2ax cubed plus 3bx squared plus 4cx plus 6k by 6. Now we substitute f of 1. Okay, we substitute f is equal to 1. We get 2a plus 3b. This should be 4c. Okay, there's a typing mistake here. Okay, it is not 4c, it would be 6c. Because LCM of 3 and 2 would be 6, and 6 multiplied with 6cx is 6cx. This should be 6cx. So we put f of 1 is equal to 6c. And therefore we have 2a plus 3b plus 6c plus 6k by 6 is equal to k. Why this is k is because k is some constant. And f of 0, if we put here, it would be k. Okay. Again, I'm majorly confused. This is k because there is a lot of typing mistakes in this. This should be 2a plus 3b plus 6a. So from here, it would become 0. And then 6k by 6 will be k. So there are lots of typing mistakes. I will totally read the problem again. Okay. If 2a plus 3b plus 6c is equal to 0, then we have to show that this equation has a root between 0 and 2. Okay. Now we let f dash x is equal to x square plus bx plus c. So integration will give us ax cubed by 3 plus bx square by 2 plus cx plus k is equal to 2ax cubed plus 3bx square plus this is 6cx plus 6k by 6. We put in the value x is equal to 1. We get 2a plus 3b plus 6c plus 6k by 6 is equal to k, because 2a plus 3b plus 6c is 0 as we have assumed here. And also f of 0 will be k, because if you put x is equal to 0, it will become k. So f0 is equal to f1, hence the equation will have at least one root between 0 and 1, which implies that it will have a real root between 0 and 2. Now we come to question 400. This will require calculus, so if you have not studied calculus, you can skip it. Most probably if you are reading algebra for the first time, you will not be able to understand this question. So you may want to revisit this question later on. Question 400 says that if ABC be non-zero real numbers such that sign of integration from limits 0 to 1 plus cos to the power 8x into x square plus bx plus c into dx is equal to sign of integration from limits 0 to 2, 1 plus cos to the power 8x, x square plus bx plus c into dx, so that the equation x square plus bx plus c is equal to 0 has at least one real root between 1 and 2. So what we do is we differentiate the given function with respect to x. So what we get is 1 plus cos to the power 8x into x square plus bx plus c. And it is given that this equation is given. So we substitute f of 1 minus f of 0 is equal to f of 2 minus f of 0. So that means f of 1 is equal to f of 2. Now the equation f of x is equal to 0 has at least one root between 1 and 2 because f of 1 and f of 2 are equal, which implies that x square plus bx plus c has a root between these two limits, that is 1 and 2, because 1 plus cos to the power 8x is not equal to 0. Okay, so between these two limits it will not be equal to 0. Or for any value of x it will not be equal to 0 because cos x value lies between minus 1 and 1. So if you raise the values to the power 8 it will be always positive, and therefore 1 plus something positive that is between 0 and 1 will not be equal to 0. So with this we come to the end of 40th set of problems on polynomials and theory of equations, and I hope you are enjoying this series of videos. I'm sorry about confusion and typing mistakes for problem number 399. I'll fix this and other typing mistakes also. So if you have not watched my earlier videos, you can watch those, and the videos are there for progressions, AP, GP, and HP, logarithm, and complex numbers. So in case you wanted to know how many more problems we will solve, we have 554 problems. So another 16 days it will take to finish polynomials and theory of equations. So I wish you all the luck for your studies and your exams. Stay tuned for the next video, which will come tomorrow. And thanks a lot for watching the video. Enjoy.